Hello everyone. As you know that I am doing strength of material previous year questions. So that is directly from the exams like GATE, IES and IAS. So this is for mechanical engineering student as well as for civil engineering students. I am dealing the topic like principal stress and principal strain. Okay, so this is about myself. So let's start. So IAS question. So I mean, I have already completed one video for for IAS exam. So that's starting from question number 11. Anyway, so if you have not watched those questions, so please watch that. Okay, so the first question for today's video is assertion. Assertion is in question. Assertion is when an isotropic linearly elastic material is loaded biaxially, the direction of principal stress are different from those of principal strain. Okay, for an isotropic linearly elastic material, the Hooke's law give only two independent material property. Okay, actually, okay, one second, I will change the pen. Okay, see, when an isotropic linearly elastic material is loaded biaxially, the direction of principal stress are different from those principal stress. No, this is wrong. Okay, for an isotropic linearly elastic material, Hooke's law give only two independent materials property. Yes, this is correct. Okay, so assertion is wrong, or reason is correct. I mean, so answer is D. Okay, next question. The principal stress at a point in a stress solid uh, are 400 megapascal and 300 megapascal respectively. The normal stresses on plane inclined and 45 degree to the principal plane. Okay, so they are asking for normal stresses inclined at 45 degree. Okay, and this is given 400 megapascal and 300 megapascal. See, so we have already know that this formula, that is nothing but sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. Okay, so theta is given 45 and sigma x is 400 and sigma y is 300. Just put this value here. So 300 400 by 2, 400 minus 300 by 2 cos 45 degrees, so you'll get 350 megapascal. So its answer will be 350 megapascal on both the plane. So answer is. Next question. The principal stresses at a point in an elastic material of are 60 Newton per mm square for tensile, 20 Newton per mm square tensile, and 50 Newton per mm square compressive. If the material properties are this, mu is this, E is this, then they are asking volumetric strain. Okay. Okay, so the volumetric strain of material is this 3 into 10 minus 4 or 10.5 into 10 minus 5, 21 into 10 power minus 5. Okay, so let's see. Yeah, see, in the previous videos we have seen the expression for strain in terms of stress. So you can see that here this is for epsilon x, this is epsilon y, epsilon z. Okay, just one second, there is a problem in the mouse. Okay, yeah, so you can see here, here and here. Fine. So what we have to do to get volumetric strain, we have to add all three. Okay, so we have to add this all three. So if you add this, you will get this expression. Okay, and once again, how to remember this formula? So just you remember only one. Don't try to remember all four. Just remember one. How? Like x, here is x, so here will be x. So sigma x minus e, I mean upon e minus mu. बचा कौन सा y एंड z बचा, तो उसको हमको सब्ट्रैक्ट कर देना है सिग्मा y बाई ई प्लस सिग्मा z बाई ई. ओके, सो दिस इज फॉर एप्सिलॉन x. y के लिए क्या करना है, यहाँ पे y होगा और माइनस कर देना है z और x वाले को. सिमिलरली फॉर z वाला यहाँ पे है तो z वाला ये होगा और x x वाले को y वाले को ऐड करके सबट्रैक्ट कर देंगे। ओके, तो आप क्या करो, इन तीनों को ऐड करो, you will get volumetric strain. They are asking volumetric strain. So this will be the expression. So everything is given. Okay, E is given, mu is given, sigma x is given, sigma y is given, sigma z is given. Okay, remember sigma z is compressive, sigma x is tensile, and sigma y is tensile. So accordingly with sign we have to put the values. Okay, so here we have to put the values in terms of sign and just simplify that. You'll get 9 into 10 to the minus 5. Okay, so the answer will be A. Next question, okay, match list. Okay, so these are the Mohr circles are given, and here few things are given. Okay, so we have to match with this Mohr circle. मतलब किसके लिए Mohr circle ये होगा? Let's see. Okay, so see, so the first is this is for two bending moment applied at free end of a cantilever. Okay, so this B is, you remember, it is like pure shear. Okay, so for pure shear means tau, only tau will be there. So so shaft under torsion. Then C1 is like, this is the Mohr circle, like here is dot, so it's a shaft compressed, is negative sign में दिया हुआ, compressed around a hub, so it is like 1. और ये वाला देखिए प्लस में है, प्लस में है, डॉट है, so this will be thin sphere under internal pressure. So this is 5. So the answer is D. Okay, this is the next question. The resultant stress on a certain plane makes an angle of 20 degree with the normal to the plane on the perpendicular to the above plane. The resultant stresses make an angle of theta with normal. Okay, with normal, the value of theta can be so like 0 or 20 degree, any value other than 0 or 90 degree, any value between 0 to 0 degree and 20 degree and 20 degree only. So this is actually B, any value under 0 or 90 degree. Okay, so this is like fixed kind of thing, like it is like fact, so you have to remember this. So the answer is B. Next question, the correct Mohr circle drawn for a point of a shaft compressed by shrunk fit hub is as O origin, C center of circle. Now OA is sigma and OB is sigma 2. Okay, so if you remember, like this match list kind of question earlier we have done, so if you remember that, we can solve this question. So this is actually D. तो इसमें देखिए compressed की बात कर रहा है, compress मतलब कि माइनस में जाएगा. ओके, तो इसमें देखिए ये प्योर शियर का है, ये तो होगा ना, ये पॉजिटिव में, ये पॉजिटिव में, यही एक ऐसा है जो निगेटिव में. तो आंसर विल बी. ओके, तो ऐसे मोहर सर्किल को देख के घबराना नहीं है, आराम से हो जाता है. नेक्स्ट क्वेश्चन, अ मोहर stress circle is drawn for a body subjected to tensile stress Fx and Fy in two mutually perpendicular directions such that Fx is greater than Fy. Which one of the following statement in this regard is not correct? Okay, तो इसमें not correct बोल रहा है, is not correct की बात नहीं कर रहा है. So its answer will be actually D. Okay, maximum shear stress is equal to epsilon x plus epsilon y by 2. ओके, फिर से इसमें मोहर सर्किल पूछ रहा है. फॉर द गिवन स्ट्रेस कंडीशन सिग्मा एक्स इज दिस, सिग्मा सिग्मा, आई थिंक दिस शुड बी सिग्मा वाई. ओके, सिग्मा एक्स इज दिस वन, देन सिग्मा एक्स हाउ इट इज 0, दिस शुड बी आई थिंक वाई. टाउ एक्स वाई, दिस इज लाइक वाई. टाउ एक्स वाई इज इक्वल टू 0. द करेक्ट मोहर सर्किल इज. तो इसमें करेक्ट मोहर सर्किल पूछ रहा है. आई थिंक यू कैन आंसर दिस क्वेश्चन वेरी इजीली. तो दिस आंसर विल बी डी एक्चुअली। ओके, इसमें देखिए एक ही ऐसा है जिसमें ये पॉजिटिव वाले में जाएगा इधर की तरफ, बाकी ये निगेटिव में जा रहा है, ये इसके ऊपर जा रहा है, ये भी निगेटिव में जा रहा है, तो दिस विल नॉट बी द आंसर। ओके, फॉर्मूला से अगर करना है तो आप सेंटर निकाल लो ना, सिग्मा एक्स प्लस सिग्मा वाई बाई 2 कॉमा 0, तो इसमें रख दो आप 1 कॉमा 0 हो जाएगा, यही 1 कॉमा 0 है सेंटर। रेडियस निकालना है तो दिस द फॉर्मूला ऑफ रेडियस, रूट ऑफ सिग्मा एक्स माइनस सिग्मा वाई बाई 2 होल स्क्वायर प्लस टाउ एक्स स्क्वायर, इसमें आप रख दो, यू विल गेट 1, तो रेडियस भी इसका 1 है। तो एनीवे यू कैन सॉल्व विद द फॉर्मूला, और ये वैल्यूज को देख के और डायरेक्टली मोहर सर्किल को भी देख के आप आंसर कर सकते हो, तो आंसर इज डी। नेक्स्ट क्वेश्चन, विच for which one of the following two-dimensional state of stress will the Mohr stress circle degenerate into a point? Okay, so these are the options. So okay, ये तो देखिए प्योर सीयर का है, anyway we'll see. देखिए इसमें एक्चुअली में सी होगा, क्या बोल रहे हैं, टू डायमेंशनल stress state of stress will the Mohr circle degenerate into a point. ओके, सो यही इसमें होगा नहीं, ये प्योर सीयर है, इसमें भी नहीं होगा, सी ही होगा आंसर। ओके फाइन। नेक्स्ट क्वेश्चन देखिए, ये फॉर्मूला बेस्ड क्वेश्चन है, इसमें ज़्यादा कुछ दिमाग लगाना नहीं, आपको पता है तो पता है, नहीं पता है तो नहीं पता है। ओके, इन एन एक्सिसिमेट्रिक प्लेन स्ट्रेन प्रॉब्लम, let u be the radial displacement of at r, then the strain components epsilon r, epsilon theta, gamma e theta are given by. Okay, so is actually b, बस आप याद कर लो कैसे आया, क्या आया, ये सब जरूरत नहीं है जानने का, तो बस इसको याद रखो। epsilon r is del u by del r, epsilon theta is u by r, और गामा r थीटा इज इक्वल टू 0, ये इट इज एक्चुअली r, ये नहीं है। ओके, इट इज r, सो द आंसर इज b। ये कुछ चीज़ें फैक्चुअल होता है, फॉर्मूला और कई कॉन्सेप्ट, उसमें उतना सोचने की ज़रूरत नहीं है, बस जो आंसर है उसको आप आंसर कर दो, दैट्स इट। ओके फाइन। असर्शन रीजन का क्वेश्चन आ गया, यूनी एक्सियल स्ट्रेस normally gives rise to triaxial strain. Okay, the magnitude of strains in the perpendicular direction of applied stress is smaller than that in the direction of applied stress. Okay, we'll see that. See, uniaxial stress normally gives rise to triaxial strain. Yes, this is correct. Magnitude of strain in the perpendicular direction of applied stress is smaller than that in the direction of applied stress. Okay, so this is also correct, but this reason is not correct explanation of assertion, so the answer will be B. We cannot say A. Okay, next question again, assertion reason question. Let's read that. A plane state of stress will in general not result in plane state of strain. Okay, let's see the other reason. A thin plane lamina stretch in its own plane will result in a state of plane strain. Okay, see, actually the assertion is correct. A plane state of stress will in general not result in plane state of strain. Yes, this is correct, but assertion is wrong. The plane strain lamina stretch in its own plane will in a state of plane strain. This is wrong. This statement is wrong. Okay, so the assertion is correct, reason is wrong, so the answer will be C. Okay, so this was the end of civil IAS question of principal stress and principal strain. Okay, thank you for watching. Bye bye.